Let's talk about one-to-one functions. This is a special kind of functions. If a function is one-to-one, then we should be able to find its inverse. So that's why I said that this is a special function. What is one-to-one function? But let me describe what a function is at first, and then we can contrast between a function and one-to-one function. A function is a rule or a relation such that all the inputs corresponds to exactly one output. Input corresponds to exactly one output. Here, one-to-one function means each output corresponds to exactly one unit input. So that's the added property of function, okay, for a function to be one-to-one. A function in which each output, the range corresponds to exactly one input. Okay, so this is something just like if we have, let's suppose, sets just like this, and each corresponds to only one output, then each output corresponds to only one input, then we say that this kind of function is one-to-one. And also we must realize that no x values or y values are repeated. So that ensures one-to-oneness of a function. Now let's take two functions and see whether they are one-to-one or not. F is a function with 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. G is 0, 0, 1, 1, negative 1, negative 1, 2, 8, and 2, negative 8. Let us draw a balloon diagram for both of these functions. Okay. Yeah, these are functions, you can check that, and we'll see in the diagram also. So let us suppose this is 0, this point is 0, 1, negative 1, 2, and negative 2. Okay, so then this would be 0, 0 would be this thing. Okay, 1, 1. So this is 1. Negative 1, 1 means negative 1 will also go towards 1. 2, 4 will be this thing. Okay, negative 2, 4 would also be this. So clearly this is a function. So f is a function. And similarly here, let us write down, this is 0, negative 1, positive 1, negative 2, positive 2. Then they corresponds to 0 to 0. Here negative 1 goes to negative 1, 1 goes to 1, negative 2 goes to negative 8, and 2 goes to 8. Right, so that's it. So this is G. Now clearly you can see that in this function each output corresponds to exactly one input. For all of this you can see that. So this is one-to-one. So this function is one-to-one. However, for these two outputs in function f, the input is not unique. Okay, the corresponding input is not unique. For 4 and 1, you can see that they don't have unique input. So in this situation, this is not one-to-one function. However, this is one-to-one function. Now, let me represent this thing by a horizontal line test. Now, let me explain what is horizontal test mean and give you some examples. Just like the vertical line test that was used to determine whether the graph of an equation represented a function or not, we have the horizontal line test, and this horizontal line test allows us to know whether graph of a equation is one-to-one or not. Okay. Similar to vertical line test, we will draw several horizontal lines for the horizontal test across the graph of those lines. Okay. Now horizontal line test refers to that if at least one horizontal line intersects the graph of the given function more than once, then the function is not one-to-one. Okay, so that means any horizontal line must not intersect the graph of a function more than once. Okay, here let's draw several horizontal lines. Okay, you can see we have drawn several horizontal lines in this dashed manner. Okay, so you can see that these lines intersects the graph of y equals to x square, the quadratic function, in two places, okay, in 2 points. So that's not an one-to-one function. Similarly, here let's draw several horizontal lines across this cubic curve y equals to x cube. Then you can see that no matter how many lines we draw, how many horizontal lines we draw, these horizontal lines intersects the graph of function in just 1 point. Okay, so that's why this is one-to-one. However, this is not one-to-one. Similarly, here y equals to e to the power x is an exponential function, and let's draw several horizontal lines. Okay, and if you go towards negative infinity, then the distance between the curve and the x-axis get lesser and lesser. Okay, so no matter how much closer we get to x-axis, all the horizontal lines crosses or intersects the graph only at 1 point. So this is also one-to-one. How about this line, this curve? This is y equals to x, absolute value of x. That's absolute value function. Is this one-to-one? Comment below.